and other two examples related to the equilibrium. So when we understand the equilibrium, we must aware the net force is equal to 0. How do we know the net force is equal to 0? Let's consider this figure first. Now we use the tip to tail method to draw the forces and found the net force. So you can see that the three forces, the combination effects, is going back to the original position. That means the net force of this diagram is 0. So by using the similar method, we can draw the FA, FB, and FC together to find the net force of it. You will find that it will pointing to the original point. That means the net force is also 0 there. And for the third figure, we do the same thing. This time we move the FA, FB, and FC by using the tip to tail method. But this time we found that there is a net force here pointing downward. So this figure is showing a diagram that the net force is not 0. Let's try the last one also. By using the same tip to tail method, we can shift the vector from the tip to the tail, and this one also shows that it's go back to the original position. That means the net force is 0. So the three figures have the net force equals to 0, but one figure showing the net force is not. That means that's not in equilibrium. Then the example 5, some idea. When something moving in a vertical velocity on a rough surface, there must be a net force. It's wrong, because when we see the word constant velocity, that means the net force is equal to 0. And when the block is moving in constant velocity on a rough surface and apply the force is acting on it, it's true. Because you can picture, if there is a rough surface, there must be an applied force in order to overcome the friction so that it can move with a constant velocity. And the Newton's first law stated that net force is needed must be wrong, because in Newton's first law it stated that if something moves in a uniform motion, the net force must be 0. So the fourth statement is correct. When no resultant force is acting on the body, then the body must be at rest. Is it true? Surely wrong, because it can be moved in a uniform motion when there is no resultant force. So the last statement, it may be at rest, is true.